Imagine 6 people are going on a triple date to the cinema together, and they've booked a row of 6 seats. Of course, each couple will want to sit together. How many distinct ways can they be seated? This looks very daunting, so let's write a sentence about it, and make sure there are no commas or full stops in it. If you're unfamiliar with this approach, watch my previous video, link in the description. I will first arrange the 3 couples, and then I will arrange how the pair in each couple sit. Now let's search for and then phrases and split into stages. The first stage is arrange the 3 couples, and the second stage is arrange each couple. Alright, now let's do stage 1. We have 3 couples and we need to figure out the number of distinct orders they can sit in. We know from the factorials video that to arrange a group of n, there are n factorial ways. So to arrange 3 couples, there are 3 factorial, which equals 6 distinct ways. Alright, now let's do stage 2. We need to arrange each couple. I don't really know how to do 3 couples at once, so I'll write a sentence. I'll arrange the first couple, and then the second couple, and then the third couple. We can clearly see now that there are 3 mini stages inside. Stage A, arrange couple 1, stage B, arrange couple 2, and stage C, arrange couple 3. Each couple has 2 people, so we can arrange them in 2 factorial, which equals 2 ways. Alternatively, you can just imagine that there are only 2 ways each couple can sit, boy left, girl right, or girl left, boy right. We have 3 stages, each with 2 ways, so by the multiplication principle, we have 2 times 2 times 2 equals 8 ways to arrange all the couples. Alright, there are 6 ways to do stage 1 and 8 ways to do stage 2. By the multiplication principle, the total number of ways to arrange the 6 people in the cinema is 6 times 8, which is 48. There's no shortcut for arranging in groups, but the key idea is that you always arrange the groups first and then you arrange how the people sit within each group. Let's try another question. How many ways can the letters of the word ace be arranged such that the vowels are together? Let's have a play with this first. Playing with the situation is always useful as it helps you get familiar with what the question is asking. In this word, there are 2 vowels, A and E, and 1 consonant, C. To arrange them, we could have the vowels first, and then the C, or the C first, and then the vowels. Alright, let's write a sentence. I will first arrange the group of vowels and the letter C, and then I will arrange the letters within each group. Splitting into stages gives stage 1, arrange the group of vowels and the letter C, and stage 2, arrange the letters in each group. Now let's look at the first stage. There's 1 group of vowels and the letter C. Note that a single letter is still considered a group, so there are 2 groups in total. The number of ways to arrange them is 2 factorial, which is equal to 2. So there are 2 ways to do stage 1. Now let's look at the second stage. There are 2 substages inside. Note that once you're familiar with this, you may not need to write the sentence anymore. So stage A, arrange the vowels, stage B, arrange the letter C. To arrange the vowels, there are 2 vowels, so 2 factorial, which equals 2 ways. To arrange the letter C, there's only 1 letter, so there's 1 way. Using the multiplication principle, the total number of ways to do stage 2 is 2 times 1, which equals 2 ways. Using the multiplication principle again, the total number of ways to arrange the letters with that restriction is 2 times 2, which is 4 ways. Alright, now you're probably getting the hang of it. Groups first, then arrange the inside of each group. Pause the video, have a go at this question, and drop your answer down in the comments. There are 5 people waiting at the bus stop. Betty and Brandon are a couple and want to wait together. The other 3 people don't mind where they go. How many ways can the people be arranged? Now let's ramp up the difficulty a bit. Groups don't always have to be next to each other, and here's an example of how. There is a noisy group of 10 Year 2 students, 5 boys and 5 girls, who sit in a row. The teacher decides that the boys and girls must sit in an alternating order. How many ways can the group of 10 students sit? This looks really daunting and I can't even figure out how to write a sentence, so let's play with it for a bit. If we imagine the students sitting in alternating order, they can either sit like this or like this. So that means our groups would be the boys and the girls. And there are only two ways to arrange the groups. There's no other way to do it. With that, I think I can write my sentence. I will first choose how the boys and girls alternate, and then I will arrange the boys and girls in each group. Splitting into stages, we have 1. First choose how the boys and girls alternate, and 2. Arrange the boys and girls in each group. We already know that there are only two ways the groups can be arranged, or in other words, alternate. So there are two ways to do stage 1. As for stage 2, let's split it up into substages by writing a sentence. I will first arrange the boys, and then I will arrange the girls. Splitting into stages, we get A, arrange the boys, and B, arrange the girls. Let's look at stage A first. There are 5 boys, so to arrange them is 5 factorial, which equals 120 ways. And for stage B, there are 5 girls, so 5 factorial, which equals 120 ways. By the multiplication principle, the total number of ways to do stage 2 is 120 times 120, which is 14,400 ways. Using the multiplication principle again, the total number of ways the students can sit is 2 from stage 1 times 14,400 from stage 2, which is 28,800 distinct ways. Wonderful! Now here's a trickier exercise. How many different 5-letter words can you make with the letters in liked if L and the K must have exactly one letter between them and no letter is used twice? This feels pretty confusing, so I'll have a play with it. If we draw out the 5 slots for the 5-letter word, we can figure out how many ways the L and the K can be placed. They could go in the 1st and 3rd spots, the 2nd and 4th spots, or the 3rd and 5th spots. If I go any further, the 2nd letter would fall out of scope, so those are the only options. So it makes the most sense to treat the L and K together as their own group. The other letters don't really have any relationship to each other, so they'll each just sit in their own group of 1. Now it still feels a bit confusing, so I'll write a sentence for how I'd craft a 5-letter word. First, I will find a spot for the L and K group, and then I will arrange the L and K within their group, and then I will fill the rest of the slots with letters. Splitting into stages gives 1. Find a spot for the L and K group, 2. Arrange the L and K group, and 3. Fill the rest of the spots. Let's look at stage 1. As we found when playing, the L and K group can go in the 1st and 3rd positions, the 2nd and 4th, or the 3rd and 5th positions. So that's 3 ways to find a spot. So stage 1 has 3 ways. Now let's look at stage 2. We need to arrange 2 letters, so that's 2 factorial, which equals 2 ways. So stage 2 has 2 ways. Now let's look at stage 3. We need to figure out how to fill the 3 remaining spots with the 3 remaining letters. It doesn't matter where the L and K group sat, it's still just 3 spots and 3 letters. So we can arrange them in 3 factorial, which equals 6 ways. So stage 3 has 6 ways. So by the multiplication principle, there's a total of 3 from stage 1, 2 from stage 2, and 6 from stage 3, which is 3 times 2 times 6, which is 36 ways. Now, if you're enjoying it so far, make sure you've liked the video. Alright, your turn. How many ways could you arrange the word liked if there has to be exactly 2 letters between the L and the K? Put your answers in the comments. Okay, now a question that looks even trickier but is actually quite simple once you find a shortcut. How many words can you make with the letters from the word liked if there must be 1 or more letters between the L and the K? That is going to be your challenge question at the end for today. Make sure to post your attempt in the comments. Alright, now let's head over to where you can grab the notes. Alright, head to my website studeroo.com.au, make an account, and then choose Math Extension 1 as a subject and you'll land in the dashboard page. From there, go to the Notes tab, and under Studeroo's notes you will find permutations and combinations and the note for this lesson below. That's the full set of notes for this lesson, ready for you to access wherever you go. You can also head to the Syllabus tab And then tick off the syllabus dot point we just covered so you always know what you've done and what's left to do. If you forget anything, you can watch the interactive video explaining it where you can click to Ask AI, which is HSC trained. And you can scroll down to check out the relevant HSC questions. Each question comes with its own interactive video, as well as a DIY walkthrough and a syllabus solution. So, what are you waiting for? Head to studeroo.com.au and start flying.